Hello everyone. Today we are going to work on the quadratic formula. The quadratic formula is used to solve any quadratic equation. Our quadratic equation's generic form is ax squared plus bx plus c is equal to 0. So we are going to use our a, b, and c and substitute them into the quadratic formula. Then it will give us two solutions where one is going to be the plus version and the other one is going to be the minus version for the same formula. Then we are going to end up with two results. Here's our vocabulary. Our generic quadratic equation is ax squared plus bx plus c. We're going to identify our a, b, and c values. And we're going to use the quadratic formula to solve any and all quadratic equations. So far, all of our quadratic equations were factorable, and the ones that did not factor, we put prime for them. But with the help of quadratic formula, we will be able to solve the ones that are even prime and that are not factorable as well. The quadratic formula has two components. Let me rewrite the quadratic formula over here. It was x, 1 and 2, negative b, plus or minus square root of b squared minus 4ac all over 2a. Now, the one component is the part it's under the square root. This part is called the discriminant. Discriminant is the part where we have b squared minus 4ac. Now, because it's inside of the square root, the value of the discriminant will determine whether we have a real solution or no solution. We all know that inside of the square root cannot be negative. If inside of the square root is negative, then you have no real roots. If inside of the square root is positive, then we have two real roots. Sometimes inside of the square root is going to be equal to 0, where our plus or minus option is not going to give us two different results, so we're going to end up with one root. Here are our steps to solve by using the quadratic formula. We will first move all the values to one side, so our equation looks like ax squared plus bx plus c equals 0. Then we will identify our coefficients a, b, and c and plug them, substitute them into the quadratic formula. And then we will solve the quadratic formula. It will give us either two solutions, one solution, or no solutions, depending on the value that's inside of the square root, which we call the discriminant. Here's our first part of examples where we will just focus on finding the discriminant, the value inside of the square root. Our quadratic formula is x12 is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Inside of the square root cannot be negative. If it turns out to be negative, then we don't have any solutions. If it's positive, we have two solutions, and if it's equal to 0, then we don't have a plus or minus option, so it will be one root. Let's identify our zeros for the quadratic part, and our quadratic part is x squared minus 5x minus 2. This is a function f of x or y is equal to. We can set a function equal to 0 to find the zeros of the function, to find the solutions of the function. We are going to write this as x squared minus 5x minus 2 equals 0 to solve it. Now I can identify my a, b, and c. A is equal to 1, b is equal to negative 5, c is equal to negative 2. I will substitute that into the discriminant, in the discriminant part, and our discriminant is b squared minus 4ac. I can do negative 5 squared minus 4 times a times c. This value will be equal to 25 plus 8. 25 plus 8 is 33, which is greater than 0. So we will have two real solutions. This will give two real solutions. Let's look at another example. We will write this as x squared minus 2x plus 1 equals 0. We will identify our a, b, and c. A is equal to 1, b is equal to negative 2, c is equal to 1. We will write this into under the square root, b squared minus 4ac. B squared negative 2 squared minus 4 times a times c. And this will give us 4 minus 4, which makes it 0. Square root of 0 is going to be 0. When we put that information in our quadratic formula, it will make inside of the square root 0, which the square root part completely be 0, and the plus or minus part is not going to give us two different solutions. Instead, we will only have one solution. So in those cases, we're going to say we have one root, one double root. So I will write this will give one solution. Or we can say double solution, because either x1 and x2 will be exactly the same. x1 will be equal to x2 and same root. By the way, root, solution, zeros, answers are pretty much going to mean the same thing in solving quadratic equations. Here's your U-try. Just identify your A, B, and C, evaluate the b squared minus 4ac, and determine whether you will end up with a single root, two real roots, or no real roots. Now let's look into solving a quadratic equation by using the quadratic formula. This function, I'm going to write it as 2x squared plus 9x minus 5 equals 0, so I can find the zeros of the function, the solution of the function. I will identify my a, b, and c. A is equal to 2, b is equal to 9, c is equal to negative 5. Now, it kind of makes sense to determine what the discriminant is. So if we end up with no solution, there is no need to continue. But if we end up with solutions, the discriminant is already a part of this quadratic formula anyway, so we will use that part in the quadratic formula. Now, discriminant is going to be equal to b squared minus 4ac. That's 9 squared minus 4 times a times c, which is equal to 81 plus 40, which is equal to 121. It turns out that this is going to be 11. And we know that 121 is a positive number, so this will give us two solutions. Now let's find those two solutions. Our quadratic formula, x1 and 2 is equal to negative b is negative 9, plus or minus square root of b squared minus 4ac, which we have already found as 121, divided by all over 2a, 2 times a. Now from this, we're going to have two different values, which will be our solutions. Let's evaluate this one more step. Negative 9 plus or minus 11 over 4. So we are going to have a solution where we use the plus. We are going to have a solution where we use the minus. So I will write two solutions in here, negative 9 plus 11 over 4 and negative 9 minus 11 over 4. This will give us 2 over 4, which can be simplified to 1/2. This will give us negative 20 over 4, which will give the result as negative 5. So we have found two solutions. Our x1 is equal to 1/2, our x2 is equal to negative 5. It doesn't matter which one you call x1, which one of the solutions you call x1, which one of the solutions you call x2, as long as you list both of the solutions. So by using the quadratic formula, we can substitute all a, b, and c values, and if the discriminant inside of the square root is greater than 0, then we are going to end up with two solutions. If we would have had a scenario where inside of the square root is negative, then we wouldn't have any solutions. Here's your u-try. Write your equation as x squared minus 2x minus 3 equals 0 and identify your a, b, and c values. First, find the discriminant part and determine if you will have two solutions, one solution or no solution. Then go ahead and apply everything into the quadratic formula and find x1 and x2 as your two roots, one root or no root. Here's our last example. Our generic quadratic equation is ax squared plus bx plus c form. Sometimes, if we have a part missing, we're just going to put zeros on that part so we don't, it will be easier for us to identify a, b, and c values. I will write this as x squared plus 2x plus 0 is equal to 0. I put an extra 0 in here in place of our c value because this equation didn't have a c value. Now I can identify a is equal to 1, b is equal to 2, c is equal to 0. We can first find the discriminant. Discriminant was b squared minus 4ac, and I will substitute everything in here. 2 squared minus 4 times a times c, which is 0. It turns out we have 2 squared, and inside of the square root is positive. This will give us two solutions, and this is 4, square root of 4 is 2. So we will have two solutions. Now we will have two solutions not because we have found 2 at the end in here, it's because this is positive. This is positive, means two solutions. Now let's find those two solutions. x1 and 2 is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Our negative b is going to be negative 2 plus or minus square root of b squared minus 4ac, which is going to be 4 right here, or I can just write 2 at the end as well. 2 times a is 2 times 1. We can rewrite this as negative 2 plus or minus 2 over 2. This will give us two solutions. Our x1 will be negative 2 plus 2 over 2. Our x2 will be equal to negative 2 minus 2 over 2. Let's evaluate each of them. 0 over 2 is equal to 0, so our x1 is equal to 0. On the second one, we have negative 4 over 2 is equal to negative 2. Our x2 is equal to negative 2. So our two solutions for this quadratic equations are 0 and negative 2. Sometimes we might need to list our solutions, so we can use the list method like this, and we will put 0 and negative 2 in least to greatest order. We can list our roots, solutions, in the brackets. Here's your u-try. Rewrite your problem as equal to 0 and make sure to add a 0 for the terms that don't exist. So we can write our equation in ax squared plus bx plus c is equal to 0 form. Identify your a, b, and c. Then find your discriminant and find your roots, if there are any, with the quadratic formula. That's pretty much it. In the class, we're going to use the quadratic formula when we cannot factor. If we can factor, we will use factoring. So we are going to determine which would be the best case scenario on solving quadratic equations.